All right. Hello, everyone. Good evening and welcome to Accenture's DevelopHER learning session on data science. Let me quickly introduce myself. I'm V. Cruz and I'm Managing Director and I lead Accenture Technologies data science capability. No? So this session is recorded. So if you are not comfortable with it, you may drop off from this call. I am very happy tonight, no, because we have teachers, graduating students, women technologists, and shifters. I'm very happy that we have a diverse mix of women here in this event. I hope that all of you will find our topic relevant. No, so imagine more and more companies and government institutions are seeing the value of data scientists. Our skills help create actionable insights. No, out of gigabytes of data. So bottom line, big data is nothing without us. And you can actually liken us as like a modern day superheroes. Today we have three speakers, no? Jera, Nona, and Mika. No? All experienced women data scientists. So they will share about what a day is like for a data scientist at Accenture. They will also talk about how do you optimize work order planning to to build and predict high maintenance models for a large retailer company. And I hope that you will learn from all of this, and this will help you participate in our data challenge after this session. Um, and of course, we have to enjoy. All of us need to enjoy this session, and I encourage you to participate in the discussions. No, post your questions or comments anytime in the chat window, found at the right hand of the screen. So with that, let me now turn you over to Jera, our first speaker.
Okay, so good evening, everyone. Thank you, Miss Lee, for that wonderful introduction. So, okay, okay, so um, good evening again. So, I'm a data scientist in a data studio and part of the data science core team in Advanced Technology Center in the Philippines, which is Eden 5. Okay, so I've been working with Accenture for almost 5 years. Okay, so I've tried different roles before pursuing the data science path. Okay, so I started as a statistician on my first job, up to a business intelligence analyst, and finally as a developer when I joined Accenture. Okay, so I only pursue data science, so way back 2017. So this is where everyone is talking about data science as the sexiest job in the 21st century. So when I first learned the data science path, so I've done some research, and to my surprise, the roles that I've been doing for the past 7 years are all connected. So as we know, data science is a multidisciplinary field of statistics, computer science, business knowledge, or any domain expertise, and many more. So I've got to learn each of its field and experience it, and now I am applying it in a more cohesive and holistic manner. So before I discuss what are data science offerings, okay, so I want you to imagine, so if you can easily access whatever you need, whatever data you need to unlock the value for your company and your clients. So imagine if you can use machine learning to segment markets and targeted promotions and detect fraud. Okay, so imagine if you can predict when a machine will fail, and if you can optimize resources to maximize losses and maximize profit, minimize losses and maximize profits rather. Okay, so here in sorry. Sorry, I lost my presentation.
Yep. So Jera, I think we can see your screen. Maybe you can share it a little or share first before you continue.
Okay. Wait a second. I got a technical problem. Okay. Can you see my screen now? Hello? Can you see my screen?
Jara, I'm not seeing your screen yet.
Okay. Let me try again.
All right, one more.
Yep.
Let's. All right, hold on.
Can you see it now?
Not yet. Maybe you could try sharing your desktop. I think that would be all right. There you go. I can see develop 2020 tech learning sessions.
Okay. Okay. So let's proceed to the next slide. Sorry about that. Okay. So I think we stopped in this part. Okay. So let's continue. Sorry for that interruption. Okay. So for here in Accenture, so we journey with our clients through data science from the business intelligence up to the artificial and applied intelligence. So most of our clients are focused on the first analytics. So this is the descriptive analytics and the diagnostic analytics or the business intelligence. Okay. So from these simple descriptive analytics, so which we use dashboards and reports to provide insight from the past and answer the question, what happened? Okay, up to the diagnostic analytics, and in which we isolate the root cause of the problem. So it typically answers why did it happen. Okay, so for the third and fourth analytics, so we have the predictive analytics. So this is where we applied the artificial and applied intelligence. Okay, so for the predictive analytics, so this were all about forecasting. So whether it's the likelihood of an event happening or forecasting quantifiable amount. So we use statistical models and forecasting techniques to understand the future and answer the question. So what could be happen or what is likely to happen? Okay, so for the last part, so this is the predictive analytics. So in this, um, we use the first three analytics to understand what has happened, why it has happened, and what is likely to happen. Okay, so to help our user to answer what is the best course of action to take. Okay. Okay, so for our ATCP data science projects have catered across these five key business domains. So these were intelligent supply chain, intelligent customer engagement, human analytics, intelligent financial crime detection, and the intelligent revenue growth. Okay, so for each domain, we have delivered at least 3 to 4 solutions. So examples of data solutions we have delivered for supply chain were predictive maintenance, warehousing and distribution optimization. While for the intelligent revenue growth, we have delivered target marketing, market basket analysis, and the net revenue management solution. Okay. Mhm. Okay, so currently we have 40 plus data science practitioners in our group, which is 8 and 5. Okay, so this is a really small number, but across Accenture, there's even more. So I've also encouraged everyone to join and be part of our growing team. Okay, so why choose Accenture? Okay, so Accenture values the growth of our practitioners. So we have curated a learning path that is tailored fit for to our resources from a data analyst role up to the senior data scientist role. Okay, so we have also catered. We also have tied up with Amazon, Microsoft Azure, Google, and Cloudera. So we are upskilling not only in data science but also as a cloud practitioner. Okay, so You can also specialize or get certifications in tool-specific training. So we have data science in R, Python, or Scala. Oh, for data visualization, we have Tableau, Click, Power BI, and we also have desk certifications and many more. Okay, so you can see we have multiple of trainings. So for these trainings to be valued, we apply our learnings through developing our own proprietary assets or POC. So we have the behavior detector and the brand performance analysis. So these POC also serves as prototypes or accelerators for our incoming clients. Okay, so at this point, you might be interested in a day in the life of a data scientist. So this is our workplace in Accenture Liquid Studio Manila, located in BGC. So you can go to this link here if you want to have a more realistic 360 visual tour. Okay, so in Accenture, we are committed to foster a more diverse environment. So where women are given equal opportunities in the workplace. So we strive to help our women access the global network to create their plans, evolve them during different life stages, and take risk along the way. So as more women pursue careers in technology, engineering, and in this case, data science, Accenture has created a unique programs to support our women employees. Okay, so now I will show you how we do the farm method and the design thinking process, which is one of Accenture's agile methodologies. Okay, so for this one, so as we start our day, so we deliver, as I mentioned, we deliver through form as the design thinking process in solving our client's problem. So design thinking process is not only a methodology, but it is a mindset. Okay, so it is a fun, interactive way as it seeks to define the problem as actively as finding the solution. Okay, so the form methodology is focuses on our users, so it is very user centric. Okay, so we partner with our clients at each stage of their data science journey. So for the first stage, so we have the discover phase. So we before we ideate or solve the problem, so we do the research and seek the problem. Okay, so we have to understand what people are doing and why people are doing it. Okay, so we will learn about the people and the context of the problem. So this is where we also translate business problems into data science problems. Okay, so heading to our describe phase. So this is where we describe with impact. Okay, so we synthesize on the insights we have gathered, and we also create persona. By the way, a persona is an informed summary of the mindset, needs, and goals typically held by our stakeholders. Okay, so going to our Okay, so the third phase is the code create. So this one is my most favorite part of the design thinking process. So it is the part where all the facts are laid out in front of you, and time to be more creative. So it is a time to ideate, time to collaborate, and think of solution to your problem. So usually we use through using of prototypes. Okay. So once you have your prototypes ready, so we can now go to the next phase, so which is the scale phase. So this is where we actually test our prototypes with actual users or to our clients. So lastly, once the users are satisfied to our prototype solutions, we need to go to the sustain phase. So this is where we deploy it in a much wider enterprise and support it through our solutions factory. Okay. So other than the farm methodology, so we also support our growing community by holding our quarterly datathon. So we also have our data science monthly monthly data science meetup and our weekly collaborative activities. Okay, so by these activities, we keep our practitioners to collaborate more, to have fun and learn, and to promote work-life balance. Okay, so I'll end with, my discussion with a quote of what it is to be a data scientist. And so it says, so our goal is to turn data into information and information into insight. Okay, so that's all. I hope you can now visualize what we do and how we make an impact. Okay, so for our next speaker, so she will talk about one of the data science application for a supply chain. So please welcome Ms. Nana.
Good evening, ladies and ladies.
Mhm.
So I see, can you see now my presentation? Can you see my presentation?
Yes.
Yes, okay. So, so I see some teachers here. Before I joined Accenture, I was with the academe. Well, I joined Accenture as I'm the lead data scientist here in 8 and 5. And like I sometimes do client presentations, but for the most part, what I do is to lead data science pods and delivering data science projects. So this evening, I'm going to share with you um, like what we're doing currently for a project for one of our clients. That is we're applying linear programming with and we integrate it with AI ML models to optimize work order planning and scheduling for a large power generation firm. Okay. So our client, so this is a challenge of our client. Our client is a large energy firm with facilities at different locations in the US. Well, work requests, so they have a group of screeners and schedulers and planners. Now, work requests go through this process of screening, planning, and scheduling. And at each step, several documents, tables, etc., may have to be referenced by the planners and the schedulers. At any given time, more than 200 work orders are being processed. So that's how large the client is. But currently, their process is manual, tedious, and prone to error. Or someone is calling me. Or sorry. Can you still see my presentation? Or, sorry. Wait. I'm sorry for that. A minute. No, I cannot find the sorry.
No, na. I
Yes,
think you have
there.
you can
Can you see
easily
now?
press Alt F5.
Yeah, can you see now?
There could be some delay, but I can see your PowerPoint, but not in presenter mode.
Not in presenter mode. So one moment. Let me do this again. Sorry. Hmm.
All right, that's better. We can see you,
Okay.
but you
But
have
not
to.
my presentation.
Yes.
Here. Okay.
All right. And
Okay. So
slideshow. Click the slideshow.
sorry.
Click the slideshow or Alt F5. It's in the file menu bar, file home.
Oh, one moment. Wait. Can you see it now? Can you see it now? Can you see my screen?
We can see your screen, but you have to put this in PowerPoint in presentation mode, Nona. You have to click the X button first.
There. I already clicked Alt F5. Can you see now? No.
Maybe you can enable editing first. Click the enable editing first, then click the Alt F5.
Sorry for this.
There.
And then
Alt F5.
Yeah, you have it. No. You can't see it yet.
Not yet, but we can see you.
So wait a minute. Can you see it now?
Right.
Someone can. Yes,
we can see it now, but it's not in a PowerPoint presentation yet. So click the slideshow or F5. Click F5.
F5.
There you go.
Okay. Okay. I'm sorry for that. Okay. So going back, no, again, anyway. So let me continue. So that's I've told you about the challenge the firm is actually facing right now, and our proposed solution. I want to give you an idea of the work of the screeners, planners, and schedulers. Like for example, the screener will have to populate several fields, and for him to decide for whether a work request can be categorized as a work order. Okay, so like for one of the fields, for example, our solution therefore is like to facilitate the work of the screeners, planners, and schedulers. Our solution is to use AI, ML, and mathematical programming. So to predict some of the field values, for example, applicable mode, need by date, the materials, work order, task duration, we use AI/ML. Basically, depending on what we're supposed to predict, like if it's a continuous variable, then we use regression. If what we're supposed to predict is categorical, then we use multi-class classification. And like sometimes we first have to do some NLP or natural language processing because some of the inputs are free text. Okay, so now once the fields are well, of course, this one already facilitates the work of the screeners. And then okay, so once the values of these fields are available, then we use some of these predicted fields as inputs for scheduling. And then with that, we can proceed to optimizing the scheduling. So to give you an idea, for example, of one of the things that we predict or pre-populate for the users is the need by date. And just for that attribute, the following rules are taken into account. The priority, the work days, that is we have to exclude the holidays. We take into account the job type, the unit, system, train, schedule group, work week calendar, scheduled outage. Just for priority alone, for example, it takes into account already the risks and criticality. So for example, if it's priority A, it has to be done immediately. The work has to be done immediately. If it's priority B, for example, then the work has to be completed within 2 weeks and all that. So like at the moment, what the screeners are doing is they look at those their documents on priorities, etc. They look at the work week calendars. They look at the scheduled outage, etc. And so that's very tedious. So with our solution, like since this one is predicted, then it really facilitates the work of the screeners and the screeners and schedulers. Okay. So for the linear programming part, so this is linear programming 101. So for linear programming, ordinarily, like with linear programming, what we do is like we have an objective function, which is either to maximize or to minimize something. In short, to optimize something. And then so we have decision variables. The decision variables are the unknowns of the mathematical programming model. And we have constraints. Those are the restrictions of the decision variables. Well, for a problem to be a linear programming problem, the objective function, constraints, and the non-negative restrictions must be linear. So like for the problem that we have with our client, for example, right now, our objective is to minimize the total time to fulfill the work orders, and the constraints that we will be considering would be the resource constraints. That is, for example, some of the resource constraints would be like each worker can only work for 8 hours, and that they cannot work, for example, on 2 consecutive shifts, and that like there's of course only a limited number of resources. For example, there may be only 100 electricians and 100 mechanical engineers, etc. And of course, we have to take into account the task sequencing. And another constraint would be, of course, to satisfy the need by date, because you cannot schedule a work order which is supposed to be completed 2 weeks from now. We cannot schedule that 3 months from now. So these are the constraints when we do the scheduling. Well, the work, this project is still in progress. And so like if you want to know more about like to read more on like some examples of the use of linear programming for scheduling, I refer you to this. Here's the URL. You might want to, like in your free time, go over this example, which was solved using Google OR tools. Okay, but for this evening, I would want to illustrate simply the formulation of problems using LP. So this is a simple example. Say, for example, you have 3 workers, each of whom can do any of 3 jobs. That is, assign each worker, So the problem is to assign each worker to one job such that you minimize the total wage. So the wage in thousands of pesos for each worker having to do a particular job is given in the following table. So just an example, for example, if you assign worker 2 to job 3, you pay 9,000. So this is what the table means. If you assign worker 1 to job 2, you pay 8,000. Okay, so this can be formulated as a linear programming problem. One possible formulation would be this. So the objective, of course, would be to minimize the total wages or the total cost, if you want to call it that. So our decision variables would be xij, that would be the number of worker, the number of worker I to assign to job j. Well, of course, this will just take on values of 0 and 1 because, well, we know that we assign only one worker to one job at the most. Well, anyway, so the objective function would be to minimize the total cost. So then the formulation of that, of the objective function would be 5x11 plus 8x12 plus 6x13, and so on and so forth. So that would be what will be minimized, subject to the following constraints. So the constraints would be, since we are supposed to assign only one worker to one job and vice versa, like one job you assign only one worker, then the sum of these must be greater than or equal to 1. The sum of these, so that would be x11 plus x12 plus x13 must be greater than or equal to 1. This x21 plus and so on must be greater than or equal to 1. And also, since for each job only one worker must be assigned, we also go vertical. So that would be, this is, for example, x12 plus x22 plus x32 must also be equal to 1, and so on. So those would be your constraints. And then, of course, to that, we have to add the non-negativity constraints. That is, of course, your x's cannot be negative. Now, so I solved this using Pulp, which is a package in Python, and I came up with this answer. So this is the optimal assignment. That is, worker 2 should be assigned to job 1, worker 3 to job 2, and worker 1 to job 1. And with this assignment, we have the minimum total cost or total wage of 15,000. So any other assignment would give total cost greater than that, or at least equal to or greater than that. So that's a simple example of LP. Going back to our client work, so the outcome of that, or the expected outcome is, so with the auto suggestion of fields, there would be no need for managers to manually reference tables, calendars, and documents. And with predictions based on what the machine learns from historical data. And optimized schedule also, with total work order processing time minimized, with resource, priorities, risks, task sequencing, and other constraints taken into consideration. And so therefore, scheduling can be done in lesser steps, in lesser time, with lesser tedium, and with lesser or no errors. So then, just a recap. The business challenge is that they're currently doing it manually, and and it's difficult for them to optimize doing that manually. And so our proposed solution is to use AI, ML, and linear programming, so that we deliver the following values that will reduce manual labor, reduce production losses, and we reduce health and safety issues, and of course, improve prediction, increase planner productivity. Okay, so let me end with this quote. It is futile to do things with more. It is futile to do with more things that which can be done with fewer. Optimize. So thank you. I hope you learned from that. So I now give you to our final speaker, Ms. Mika Mata.
Thank you, Miss Nana. So let me share my screen. Can you see my screen?
Yes, Mika.
Okay, so again, thank you, Miss Nona. So, good evening, everyone. I'm Nika, and I'm also a data scientist from the Data Studio. I am actually a career tech shifter. So, like some of you, I am not an IT professional. I was a human resource specialist. So, my previous work centered around using employee data in creating programs and initiatives that can impact employee productivity and engagement. I became interested in data science upon knowing that there's a more efficient and effective way of getting insights from big data. So my data science journey started when I became one of
the FTW, or for the Women Foundation Scholars, for their data science program. After graduation, I joined Accenture. I was able to complete several data science projects and learn about three different industries. And tonight, I'll be sharing with you one of our projects that my team did, entitled how we were able to create a predictive maintenance solution called PMU using multi-class classification for a large power retailer company. So this project is actually under the intelligent supply chain domain shared by Miss Jera earlier. So let's start with a quick trivia. Did you know that there are 5 million wooden poles in Australia? And a single pole failure means no electricity for almost 10,000 customers. Unplanned repair of this pole will cost the business approximately $100,000 per hour of downtime, labor and parts replacement costs, and the need to deal with customer complaints. So recognizing these business cases, one of the utility companies in Australia partnered with us to create a solution that can improve power network by reducing unexpected power interruptions due to pole failures. So we combined industry expertise and data science to answer the following question. Which poles will fail? When a pole will fail? And what is the recommended maintenance step for those poles who were identified for failure? So after finalizing the business requirements, we moved on to data preparation. I'm sure you'll agree with me that this phase takes up to 80% of the data scientist time. It requires a lot of effort to understand the data, clean it, and sometimes we need to do feature engineering to get the right variables for our models. So for our project, here are the top 2 pain points that we have encountered. So 17 out of 32 features have 10 to 54% missing values. So the team decided to fill these missing values by using the mean for numerical features and the mode for categorical features to address that pain point. Our second pain point is or was there's no historical pole failure data. What's the importance of the historical failure data? In any predictive maintenance model, failure history is a requirement. The model learns from the failure history, the why, and the when a particular equipment fails. So to address this, the team decided to use the age or the estimated lifespan of the equipment or the pole and the last inspection date to predict when will a pole will fail. So we feature engineered the age or the estimated lifespan of the pole by subtracting the last inspection date from the installation date. After preparing the data, we did the model building. We actually used supervised machine learning algorithm to answer the 3 questions we have earlier. So to answer the first question, to predict which pole will fail, we use binary classification. So the output is yes or no. To answer the second question, or to predict when will the pole will fail, we used a simple linear regression. So the output is the date the pole will most likely to fail, but I want you to take note that this is not based on time series data since we don't have any data on the failure history. Thus, this prediction is solely based on age or the estimated lifespan of the poles. And to answer the third question, or to answer what maintenance treatment should be done to the pole, which will fail in a specific period of time, we use multi-class classification. So the output can be no treatment, or if the pole is due for replaced or for repair. So example, let's say we have pole 1. So pole 1 was classified as yes to failure by the first model. The second model will predict when pole 1 will fail. So let's say it outputted May 2021. The third model will then recommend what treatment should be done to pole 1 so that the client can prevent pole failure, and unforeseen power supply interruption. So that's for the model building phase. We evaluated the performance of the models based on accuracy and error rate. So for classification, we initially used logistic regression, KNN, random forest, and a decision tree. So I'm sure most of you who are into data science are very familiar with these models because these are a set of classical models or the most common used model for classification. And these are the accuracy. We decided to improve the accuracy of our classification algorithms by using ensemble method. So for those who are not familiar, ensemble method is a machine learning technique that combines several base models in order to produce one optimal predictive model. So in our case, the ensemble method that we use is a stacking ensemble method. It combines the predictive power of our base algorithms, which are the logistic regression, KNN, random forest, and decision tree, to create the final model that yields the best accuracy score. So as you can see, the ensemble method has a 96.04% accuracy. So for the simple linear, for the regression algorithm, we use simple linear regression, and the error rate or the mean absolute percentage error is what we use to measure the prediction accuracy, and it yields 2.03%. Our R squared is actually 97.7%. So PMU, this is the title of the asset that we've created. PMU's machine learning algorithms are available to the users via dashboard. So this is a quick snippet of that dashboard. So as you can see on the upper left, you can select the forecasted year here. Below it is the summary of the total number of the predicted pole failure, both in whole number and in percentage. Next, you can select here the area for investigation. So for this project, we use polls from 3 areas or 3 zones. These were provided by the clients to us. Then we have the treatment distribution table where you can see how many polls are going to fail in a specific period of time and how much of them are for repair, replace, treatments. So example, I want you to zero in here in May 2020. So on May 2020, we have a total predicted poll failure of 394, and 203 out of the 394 are due for replacement and 191 are for repair. So at the bottom section of this dashboard, you can see the equipment list table where you can find all the details about the pole for easy reporting. So here's the equipment number, the forecasted failure date, what else, and its characteristics, like for example, the size. So now you may ask, how can the client use this dashboard? So imagine that I am a maintenance work order scheduler. So my task is to create an appropriate asset maintenance routine. So this dashboard will make my job easier and faster by giving me insights on the number of poles that will fail, when, and where. It will also recommend what type of maintenance treatment the unhealthy poles need. So since this asset shows how many unhealthy poles are due for repair or replacement, I can also use that insight for my replacement program planning. So example, I can prioritize those poles due for replacement based on volume and proximity. So example, here in zone Z32, zone T332, I'll mobilize my engineers here first because this is where the bulk of poles due for replacement are located comparing to the other 2 zones. So additionally, I can infer possible reasons for pole failure based on the analysis. We found that those poles without CCA treatment, CCA is an anti-termite treatment that utility companies use for their equipments. So Our analysis found that those polls without CCA treatment are more prone for replacement than those polls with CCA treatment. We also found that polls with bigger diameter size, those polls require less maintenance actions than those polls with smaller diameter sizes. So all of these insights are available to the user via a report that can be generated from the dashboard. So aside from this information, what are the other benefits of this asset? So PMU is projected to improve business operations by reducing maintenance costs by 30%, eliminates breakdown by 74%, and 45% reduction in downtime. So that's PMU, ladies. To summarize, again, we were tasked to reduce electricity downtime due to unforeseen pole failures by improving maintenance strategy. So we use different machine learning methods to predict pole failures and recommend necessary maintenance treatment. And we were able to reduce maintenance costs, eliminate breakdowns, and reduce electricity downtime. So allow me to end this demo by leaving you with this. So prevention is better than cure, but it's even better if it's powered by data. Thank you, everyone. So if you have questions, please feel free to type them in. Back to our lead, Miss V.
All right, thank you very much, Mika. No, so again, everyone, hello. We hope that this has been fruitful to you, no, and at this moment we would like to answer some of the questions, no, and I have here one, and I will call this one is for you, no, Jera. One question here is about. Let me just go to that question. Okay, let me just a lot of questions already, and I think some of you have seen that or some of our one of our moderators has responded, no. So this one goes to Jera about let me just do this. Okay, let me just scroll a little bit. All right, here, no? Says, what does it mean for constraints, variables, etc. to be linear? And what are the examples of linear versus non-linear? Jera?
Okay, hi po, Miss V. Okay, for a constraint to be linear, so it does just means that your constraint are in first degree. So for example, if you increase once you increase your constraint, it will just increase or decrease. But for the nonlinear, your constraint would be on quadratic or cubic or even on the high power of something like that, which is much more difficult to predict rather than the linear programming.
All right. Thanks, Jera, for that. No. Okay. I guess we can still accommodate one more question. So I will bundle questions related to trainings, no, and upskilling or with what we call upskilling. So questions related to one, if we came from STEM background, do you have training available for data science? And another question related to it is if we are non tech or shifters, do you also have training available for data science? And I would like to ask, no, Jet De Los Santos, who leads our data science capability as well in the Philippines. Jet, do you mind responding
Yeah,
to?
sure. Yeah, sure. Thank you, V. Yeah, just to share, right? And just to share, right now we're looking for actually for experienced professionals with at least 2 years experience. But we do have some data scientists who did not really come from those backgrounds that you mentioned. So here in Accenture, we provide bootcamp specific for data science practitioners as they journey from earlier Jera mentioned about that, right, from a data analyst role, and then as they grow and upskill right, and level up in their proficiency, they up to the data scientist and senior data scientist levels, right? So we do supplement any background, even those who are coming from outside with the relevant experience and background. Within Accenture, we continue to upskill them. We continue to curate learning contents for them, including even specialization in certain functional domains. So yeah, hopefully that answers the question that you guys posted. Thank you for the question.
All right. I think okay, I think that's all we have for the questions. So there's a lot of questions here, no, but we will compile, no, and respond to these questions, and hopefully we can share to you. Okay. All right. So here let's now, no, proceed to the data challenge. And so by the way, no, all participants who complete this session in our data challenge will get an e-certificate, giveaways, and a chance to win a special prize. No, and I'm gonna call in Mika to talk about our data challenge.
So thank you, Miss V. So again, all participants who complete this session and our data challenge get an e-certificate, giveaways, and a chance to win a special prize. So the data challenge is open only to individuals, not to teams and partners. So this is the challenge. We challenge you to create, design, and develop solutions, conceptual or prototype, that can be realistically applied to solve the problem statement. So this is the problem statement in the screen. So let me read it now. So using the publicly available data sets from Open Data Philippines, formulate a scheduling problem and come up with data-driven solutions or strategies. So an example is a scheduling scenario is the timetabling of MRT train schedule and frequency using the government's data on daily passenger traffic who have entered and exited per station. But of course, participants may also opt to formulate solutions or strategies for this specific problem if you're interested. So you will be judged according to how innovative your solution is, the impact it can create, and your presentation. So you have the rest of the weekend to work on a PowerPoint presentation and send it to us by Monday, May 18th. So once reviewed, we will schedule a call with you and our data science experts to present your idea. Do not be intimidated because they will support you to improve your idea. So you will have a chance to win a brand new Amazon Echo and Starbucks loaded card when you participate to this challenge. So are you ready? So we'll send you an email for more details. So again, this is the judging criteria. So for now, I hope we made your night complete and we help you set your career right. We hope to see you in your presentation next week. Lastly, we'd love to hear your feedback on tonight's session. So please go to menti.com and use the code 472065. So one of our marketing team will ping the code to answer our short survey. Thank you and good night.